Hello, everyone, and thank you for joining us today. My name is Anna, and I'm a product specialist for Revit at Chaos Group. I'm very excited to welcome you to this V-Ray Next for Revit webinar. I know it's been quite a while since the last time we released a major version, but as you're going to see, it was totally worth the wait. In today's session, I will guide you through all new features and improvements we've packed in this release to bring your renders to the next level. V-Ray Next for Revit features powerful asset management through a brand new asset editor, new custom content possibilities with V-Ray scene files, as well as a large number of smart new tools that will make your work in Revit more efficient. All these, combined with the scene intelligence and performance optimizations V-Ray Next is famous for, make it our most powerful release for Revit yet. Shortly said, V-Ray is now better, smarter, and faster. And on top of this, it helps Revit make things it couldn't do before. To prove my words, now's the time to jump into Revit and start showing you. I will be presenting using the following office building project, which was designed for the purposes of this webinar. The model is shared over a central file, and during the webinar, my colleagues here will also be using it. We will show you how V-Ray Next can easily be utilized in a collaborative Revit environment, allowing you to share assets as well as entire rendering setups. The first thing that you notice once you turn on V-Ray Next for Revit are the lovely brand new toolbar icons. The Assets panel immediately draws attention as the greatest changes are there. The added V-Ray logo icon reveals our most important new feature, the Asset Editor. It comes in place of the standalone material editor, which some of you might know from V-Ray version 3. Its extended capabilities and intuitive design make it a full-featured place not only to create or edit materials, but to browse and manage your entire material library and collaborate over it. If you have used V-Ray for SketchUp or V-Ray for Rhino, you will notice that the asset editor has a uniform UI across these apps, making it easy to jump from one app to another, as well as to share, transfer, or reuse assets. The asset editor, as you can see, is organized in three expandable panels. When starting a new project, the mid panel, which is the one that loads by default, appears empty. This indicates that no V-Ray materials have been created yet in the project. So let's start with expanding the side panels and explore how exactly to navigate. The left panel provides direct access to V-Ray's built-in material library, which contains over 500 ready-to-use V-Ray materials and is conveniently organized into thematic subfolders like bricks, concrete, metal, etc. Clicking on any subfolder will allow you to preview and browse through its content. You can customize the gallery preview upon your own preference by selecting between list and grid preview, change the displayed size of the preview items, and select between row and column layout as well. In my setup, I would prefer the column layout and the list preview. Right-clicking on any material opens a context menu where the Add to Scene option allows you to add the selected material to your current project. Respectively, the material appears in the mid panel, and as this is the first material we've added, the Materials tab icon is highlighted in blue, indicating that now the tab has content. The other option in the context menu is Delete. Beware when using it, as it won't delete just the preview but the whole material from your hard drive. I'll continue adding materials, and another way to do it is to simply drag and drop them over the mid panel. Now that we have already added some materials, we can expand the right panel where you can explore and modify all material parameters. In terms of UI, this panel looks very similar to the standalone material editor which we had in version 3. You can toggle between basic and advanced display mode from the button over here. or change the type of the live preview swatch from the following context menu. Now let's say that we want to create a material from scratch. Materials and texture maps can be created either by using the menu at the bottom of the mid panel or by right-clicking on the tabs at the top. The first tab is for materials, the second one is for textures. By right-clicking on any of both tabs and holding the Control key on your keyboard, you can create multiple items. Let's create some textures. As you might know, V-Ray offers a large number of procedurally generated maps to alter any material's appearance. Some textures mimic the diffuse colors of various surfaces such as granite and marble. Others provide data for use in compositing. There are also a number of utility textures for color correction and blending. After we have created textures, now both our tabs are highlighted in blue. The blue color indicates that the tab is active and its content is visible in the list below. You can switch between both of them or select them together by holding the Alt key on your keyboard. I'd prefer to focus on the Materials tab, so I will select it. The mid panel serves as an outliner and displays the hierarchy of the shader structure, meaning that you can check what the shader contains at a glance without having to click individually on any texture slot. Okay, we already have materials. Now let's see how to actually assign them to Revit geometries. For that purpose, I will open up the Appearance Manager. Formerly, this window was known as Asset Browser. Now, as the name suggests, it controls how Revit materials and families appear when rendered with V-Ray, meaning that you can replace them with photorealistic V-Ray assets without affecting your BIM model and its size by any means. Furthermore, this approach allows for a certain level of detail where Revit assets, which can be quite schematic, are used for constructive documentation, while at render time, V-Ray will help you enhance the picture. Thus, you can do both things from within Revit using a single model. As you can see, the first tab is called Materials and it displays a list of your Revit project materials conveniently separated in expandable groups by linked file. There is a search bar at the top, as well as a filter menu on the right. Let's search for a grass RVT material, and you might have noticed that there is a tiny V-Ray logo icon next to each material. Clicking on it displays a list of all V-Ray materials that are saved and available in that particular project. Respectively, it's the same content that we have in the Asset Editor's outliner. I'll select the Grass C material. After being assigned during rendering, V-Ray will use it instead of the Grass RVT material. However, if you don't assign any V-Ray materials, your Revit materials will still be automatically converted to V-Ray ones at render time. One more thing, at the bottom of the panel, you will find transform settings which refer to the assigned V-Ray material. They will help you adjust the map size and orientation of the assigned V-Ray material. We'll explore this later on again. Multiple selection is also supported when assigning a V-Ray material or adjusting the transform settings. You can remove the V-Ray material assignment from the X button right next to the material name. Next time you click on the drop-down, the last assignment you did will appear automatically. Now let's go back to the asset editor. Besides that you can browse the built-in material library, you also can add a custom library folder, and in case it is stored on a network location, it can be shared across all members of a team. I just added my custom library folder and it appeared along with all its subfolders. Now, if I want to add a material to the library, I can navigate to the outliner, select a material, and drag and drop it over here. This will save it in the library. And if I modify any of its parameters and drag and drop it again, I'll be asked if I want to replace it. I'll now delete it. In cases when the library is shared and coworkers are also contributing to it, you can refresh the content by right-clicking on the respective folder. Other actions that you can perform are save asset to file, which will save it as a VRMAT file compatible also with V-Ray for SketchUp and Rhino, as well as import asset file, which again refers to VRMAT. At any time, you can do a purge, which will delete all non-assigned assets. Now to start rendering, I will drag two materials from my library. Then I will go to the Global Overrides tab of the Appearance Manager. Here you can override opaque and transparent materials all together at once and focus on the lighting setup. Another use case is for schematic renders at early project stages. For that purpose, we have also added the Revit shading as an optional override mode. The global material assignment works in the same manner as I already showed to you. I'm using the same material for opaque and RPC override and another one for all transparent surfaces. And it's time to start the rendering. I have a fast GPU, so I'll select to render using it. I will also navigate to the Channels tab and enable our new AI accelerated denoiser engine by NVIDIA. It uses artificial intelligence to estimate what the image should look like without the noise. Since it does this super quickly, it is perfect for scene adjustments during interactive rendering. Mind, however, that it requires an NVIDIA GPU to work. As for my render setup, I'm using the crop region resolution, medium quality, and the current view is set to the exterior you currently see. So here is what we have initially. The first step will be to replace the RPC trees with photoreal ones. I will go to the Objects tab of the Appearance Manager. This tab has been extended to host not only RPCs but also other Revit family categories which we considered suitable for rendering. I have replaced all RPCs with V-Ray proxies in advance. In this version of V-Ray for Revit, we've also made it possible to override Revit families with another V-Ray format, the V-Ray scene. This will be covered later on in the webinar. The UI of this tab has also been modified so that the settings are visible all the time at the bottom of the panel, and the current workflow would be first to select an item or multiple items and then tweak the settings. Now, we'll focus on another handy new feature, the randomizer. When having instanced Revit families overridden with a V-Ray geometry, it allows you to easily assign random scale and rotation to that geometry. In previous versions, this process was tedious since it required several RPC types to be overridden separately and assigned separate scale and rotation. Now things are streamlined and you can create natural looking entourage even when using a single RPC. You only need to assign minimum and maximum range for both scale and rotation, like this. You might need to play with it for a while in case the current randomization is not what you were looking for. Swap between different random combinations using the Refresh Random Seed button. I don't want to see any tree leaves in the foreground, so I think that this will be my final setup. So in terms of geometry, this is what I'm going to see in my final image. My next step is to set up the lighting. First, I'll adjust the sun position so that the light is reflected by the waterfront elevation of the building. As a general guideline, use the light to emphasize the shape of the building. I'll combine the sun with another new feature, the custom background. It is quite similar to the dome light in terms of UI. It does not emit light though. The best way would be to use it combined with the sun so that you'd have the well defined shadows by the sun, plus a nice cloudy sky. In the image preview, camera and true north indicators will help you position the image. I'll adjust the settings and we'll have to decrease the exposure value a little bit to make the image brighter. And since in reality remote objects fade away, I will enable the aerial perspective effect. This is an effect similar to fog and haze, which is caused by the Earth's atmosphere when objects are viewed from a distance. Another one of the VRNext advantages is that these effects were optimized to work on GPU. The parameter names are self-explanatory. The fog effect spreads downwards the specified atmospheric height. The scatter multiplier refers to the amount of light scattered through the fog, while 1 is its physically correct value, smaller or larger values are used for artistic purposes. As for the view distance, smaller values mean more dense fog and vice versa. I've set the height to 30 meters, as that would be enough to slightly wash out the background buildings while also having the bright line effect on the horizon. Now let me stop the rendering for a while, press escape to close the settings panel, and let's open the asset editor again, as our next step would be to start working on the materials. For the water, I will use a waves material from the V-Ray library. I will then disable the can be overridden setting. This will exclude that particular material from the global override. Let's assign it and run the interactive rendering again. I will now draw a render region around the water and will then adjust the map size and rotation. I will also tweak the diffuse color a bit. This material was meant for deep water pools like seas or oceans. That's why it has no refraction. It uses only diffuse color and reflection plus bump for the waves, so I can just tweak the diffuse color until I get the result I want. I'll continue with exploring some very common shader types which previously haven't been available in V-Ray for Revit, yet they introduce endless possibilities for recreating real-world materials, including such with very complex surfaces. So next material will be the waterfront sidewalk. Since I want to have water puddles on the ground, I'll create it by blending two materials together. I will use asphalt material from the library and will also create plain water using a generic material. I'll rename it to asphalt puddles. As we don't need any ripples or waves, the setup is quite simple. Black diffuse, almost white reflection and refraction, and IOR set to 1.33. Now I'll create a blend material. Set the asphalt as a base, click the Add Coat button, and assign the puddles as a coat. Now to mix them together, I'll use a noise B texture. Again, I'll unmark the can be overridden setting, rename the blend material, and assign it. The noise needs some adjustments. I will increase its size and will change the levels so that the transition between both colors is sharper and will then change the material scale. It already looks like puddles, however, I don't like the way they are positioned. The noise phase parameter can help me adjust the positioning as it regenerates the randomness of the noise pattern. And one final thing, I'll set the color B of the noise texture to light gray so that the asphalt material below the water is also considered. If I leave it to white, only the coat material will have an effect on the final result. And another material that I'm going to create is a two-sided material. It is very useful when simulating thin translucent surfaces like paper, curtains, or like in our case, tree leaves, as it allows seeing the light on the backside of the objects. Similarly to the blend, it has slots for plugging in materials. I'll create basic tree leaves starting from a generic material. Probably you've noticed that clicking on any empty texture slot opens up the texture menu, which we explored at the beginning. This time, I'll create a bump texture from the menu on the Textures tab. I have a JPEG of a tree leaf here, and then I'll drag and drop the texture to the diffuse slot of the material. A menu appears prompting me to select whether I want to assign a copy or an instance of the texture. This approach can be applied to any texture and in any material's texture slot. I have also prepared a black and white map for the opacity slot. Our leaves are almost ready. I will add some blue tinted reflection as if the leaves reflect the sky, and I'll also reduce the reflection glossiness to blur the reflection. I won't use any bump because I don't have any leaves in the foreground and respectively I don't need that much detail. Now I'll duplicate the material and will rename it. This will be our front material for the two-sided material. I will right click on the diffuse texture slot and will then select to wrap in the current texture in a color correction. It is one of the most useful utility textures, which allows us to color correct maps without using any other applications. I'll slightly change the saturation of the leaf. Now I will duplicate the material once again and will also adjust the hue and saturation of the duplicated material's texture. I'm ready to plug in both materials to the front and back slots of the two-sided material. Before I run rendering again, I'll remove the RPC proxy override and will set the missing material's color to light gray. The latter is necessary because proxies come without any V-Ray material assignment, so initially they will render in the missing material's color. I'll assign the leaves and will render. I'll assign the basic leaves material to the bushes and to the trees that are less visible. And I can do some final adjustments to the exposure and background. Meanwhile, my colleagues have just informed me that they're ready with the rest of the materials and mapping, so I will stop the rendering and will synchronize with the central model. In V-Ray Next, we've changed the way V-Ray settings are saved, making it possible to have common V-Ray materials in a work shared project while the rest of the settings are individual. As you can see, after the synchronization, my asset editor displays all materials that my colleagues have created, and that's awesome. I will also need to adopt the exact materials mapping, so I will go to Settings, Paths and Sharing. In the Load from Project Storage drop-down, I can see my colleagues' usernames. When selecting a user, their settings appear in the list below, grouped by category. I will leave only the V-Ray mapping, and we can check in the Appearance Manager if the import was successful. Seems like it was. And we don't need the global material override anymore. Let's render. We might need to adjust the exposure again. The image is getting nicer, but let's say we need to make a last moment change. In our case, that will be the tree leaves. I would like to turn them into autumn trees, so I will go and adjust the color corrected textures a little bit more. A thing that I missed to mention is that you can control which side of the two-sided material, front or back, is more visible by tweaking the translucency parameter. We still have some green trees over here. I'll assign them with the darker orange material to add some color variety. Now, as promised, some insight on the V-Ray scene linking, which is also part of our latest features. Any item in the Objects tab can be replaced either with a VR mesh or with a VR scene file. While VR meshes require creating their materials in addition, VR scenes are in a ready to render shape containing everything geometry, materials, and even lights. Some V-Ray host apps like 3ds Max are famous for their render ready content. With V-Ray Next, you can take advantage of all this and bring it into Revit like never before. In my project, I've exported some fallen autumn leaves as we are seen from SketchUp, and I have placeholders for them which I will unhide. V-Ray scenes can be randomized in the same manner as we saw at the beginning. The next tool that I'll show you is the Pick Focus Point tool. First, we need to enable the defocus effect. Let's set it to zero point 0.6. Then select the Pick Focus Point tool from the toolbar and click that object in the Revit view, which you would like to appear in focus on the rendering. Notice how after we click on the lamppost, it is now in focus. Let's repeat it again. And finally, I think that we can slightly decrease the defocus amount. Now, let's do some color corrections to the final image. I'll decrease the highlight burn and will adjust the contrast. I'll also adjust the color balance by adding warmer tints to the shadows and midtones and colder to the highlights. And finally, I'll adjust the curve. I can also save these corrections as a preset and reuse them later on. Now, another colleague of mine is working on a night rendering setup, so I will do a sync to Centro to get any recent materials and then we'll adopt his settings. Before starting the rendering though, I'll right click on the image and select Save to Project. This will save it to the project under Renderings. Mind that whichever render element is selected in the VFB, that element will be saved to the project. Let's turn off color corrections, hide these objects, and render. A quick glance at the environment lighting settings we just adopted. I would adjust the artificial lights. However, they belong to various family types, and adjusting them one by one might take too long. So I'll use the artificial lights override settings instead. These settings provide global control for the intensity and color filter of the artificial lights. The color of all lights will be overridden with the selected filter. As you might guess, this allows for a lot of artistic effects. Emissive materials can also be included. And increasing the intensity to 3 will make the lights 3 times brighter. Now let's enable aerial perspective again. These settings have also been adopted from my colleague. As you can see, lower height can be used for artistic purposes. I will adjust the settings. and we'll add environment fog as well. First, I'll enable the artificial lights to have an effect on the fog. Then I'll adjust the density and the height. And we'll paint it in light blue. Once I'm done, I'll also make some slight corrections to the exposure and white balance. I think the water also needs to be adjusted a bit. And I guess you are wondering how the wet asphalt material was created? It uses again a noise map, but this time in a simple generic material. Noise is once plugged in the reflection slot, where light gray means more reflective while dark gray is less reflective. And it is also used in the bump, where instead of color, in color slot A, we have plugged the normal bump map. I will now import another set of color corrections. And with this, our image is ready for a final touch with the redesigned lens effects of V-Ray Next. They will help us make the lights glow as if the image was taken with an actual camera. In reality, blooming occurs when capturing extremely bright light. Camera sensors cannot process the entire amount of light, and a halo appears around the light source, while glare introduces the starry look around light sources, which is the result of light passing through a narrow camera aperture. The first thing you'd notice is the aperture preview, which updates every time we modify the parameters. The bloom slider controls the transition between bloom and glare. A value of 1 will force only bloom without any glare. You can set a threshold which pixels to be considered by the effect, as well as to play with the intensity to boost it and simulate up to 20 times brighter light sources. You can also specify whether you want the effect toned in cold or warm hues. And one more thing, the number of glare gleams is controlled by the blade's size parameter under aperture shape. You can also simulate lens dust or scratches. I won't go into more details here though, as the rest could be reviewed in an advanced webinar. Okay, so let's go back to my slides for a while, as we are now going to discuss one of the major aspects of V-Ray Next, the scene intelligence. It's all about getting the right image more easily and quickly. We've already explored some of the features you see in my list, like the AI denoiser by NVIDIA, which will help you get a fast preview in interactive, as well as the GPU acceleration for environment effects. The latest GPU improvements include also compatibility with buckets rendering mode, better multi GPU performance, as well as support for more features previously available only on CPU. We'll now have a look at V-Ray Next's smart new camera settings that can set your camera exposure and white balance automatically, just like a point and shoot camera. We will then continue with exploring how you can measure your design's light levels. For that purpose, I've prepared the following interior scene. Since V-Ray Next includes also support for Revit decals, we have added a decal depicting a world map at the background. You will find the auto camera mode next to the exposure value and white balance settings in the camera window. Mind that currently these settings will produce the desired result when production rendering mode is used. I will first render the image underexposed, and as you can see, it is quite dark at the moment. Now, if we enable the auto exposure and draw a render region and re-render, we can see the difference. And now let's include the auto white balance as well. Alright, now let's continue with the lighting analysis channel. You can enable it from the Channels tab of the V-Ray settings window. The lighting analysis can help you visualize, understand, and evaluate the true illumination levels of your design. It works for both daylighting analysis and artificial lighting levels from fixtures. The displayed result appears either as a color gradient from blue to red or as exact values positioned on a grid. For now, I will keep the default settings and will only change the display mode to grid overlay. I will start an interactive rendering, and as you can see, the light analysis starts approximating the lighting to give you a quick preview. However, if you want the most accurate results, we would recommend doing a production render using high or very high quality preset. Another thing that you might have already noticed is that currently there are missing values on the entire glass surface. This could occur when rendering glass and mirror surfaces, just like in our case, where V-Ray has computed the luminance of the glass but not of the surfaces seen through the glass. In such cases, you could render using high or very high quality preset. But another way to overcome this is to specify which channels to be affected by the glass refraction. Find the glass in the asset editor, switch to advanced mode, find the affect channels parameter under the refraction rollout menu, and set it to all channels. This time I will run a production render and wait for it to finish. And after that, I can continue tweaking the light analysis parameters and update the render result using the update button. We can, for example, adjust the grid spacing so that we can see more values. And we can also adjust the minimum and maximum values, where minimum is mapped to blue while maximum is mapped to red. Let's switch to false colors. To better understand what these colors represent, we can also select the Draw Legend option. A mapped legend scale appears at the bottom of our image, indicating the lux values for each color we're seeing. Last but not least, a few words regarding V-Ray's smart new adaptive dome light algorithm. It's enabled by default and you can find it under Renderers tab optimizations. It is super quick for interiors and in general can cut your render times in half and more. I've rendered two images in advance, respectively with and without dome light enabled. While they both look nearly the same, the one with adaptive dome light on rendered 2 times faster. It's the one that you see on the left. Alright, we saw many new features in action today, and it's time to summarize what we've learned. V-Ray Next complements your workflow with advanced rendering tools, which will help you in producing high end photorealistic visuals straight out from Revit. Keep your V-Ray assets organized, share them with your colleagues, and collaborate the way you are used to doing it in Revit. While keeping your BIM clean, V-Ray also provides you with various out-of-the-box solutions to customize your rendering content according to your own design needs, like the examples we observed with VRScene and VRMesh files. With a set of smart new tools, you can now render twice as fast on average and focus your efforts on the actual design of your model and be more efficient. You can try VRNX for Revit free for 30 days. The trial is available on our website following the link you see on the screen. We are close to the end of this webinar, so I would like to thank everyone for attending. I hope it was helpful enough to get you up and running with V-Ray Next for Revit. If you want to stay up to date with what's new, check our website regularly. A lot of useful information and examples can also be found on our documentation page. For more video tutorials and past webinars, subscribe to our YouTube channel. Your feedback is our main driving force, so keep on giving it. Thank you, everyone, and see you next time.